Hello, good morning. Today's lesson cams. In cams, flat follower with a uniform velocity, flat follower with a simple harmonic motion, flat follower with a uniform acceleration and retardation. Objectives of this lesson: on completion of this period, you would be able to draw cam profile when a follower moves with uniform velocity, number one. Number two is to draw cam profile when a flat follower moves with simple harmonic motion. And third one, to draw cam profile when the follower moves with uniform acceleration and retardation. And these three things let us discuss in this lesson. Flat follower with uniform velocity. That means to draw the cam profile for a flat follower which is moving with uniform velocity. Let us solve one by one by using problems, solve examples. Draw the profile of a cam to give the following motion to a reciprocating follower. To a reciprocating follower with a flat contact face. Flat contact face. And having the following outstroke during 120 degrees of cam rotation, and dwell for the next 30 degrees of cam rotation. Return stroke during 120 degrees of cam rotation. Dwell for the remaining 90 degrees of cam rotation. And the stroke of the follower is 30 mm and the minimum radius of the cam is 25 mm. The follower moves with uniform velocity during both outstroke and return stroke. The axis of the follower passes through the axis of the cam shaft. So here in this case, we have to draw cam profile for a flat faced follower, and its stroke length is 30 mm and minimum radius of the cam is 25 mm, and the angles are given for us. And the velocity, there's a motion of the follower is uniform velocity in both outstroke as well as return stroke. So that will be the data here. Let's have the solution. Cam rotation during outstroke 120 degrees. Cam rotation during dwell period is 30 degrees. Cam rotation during return stroke is 120 degrees. And the remaining part of period will be 90 degrees. Stroke is equal to 30 mm and minimum radius of cam 25 mm. First of all, in this solution for this problem, we should draw displacement diagram for uniform velocity. For uniform velocity displacement diagram, we should have the cam angles as well as the lift and type of motion. These three are required. Already we got these three, and here in this case, y-axis represents the lift of the follower, x-axis represents the angular displacement of the cam, and now let us take suitable scale. On x-axis, 10 mm is equal to 30 degrees, and And also y-axis 10 mm is equal to, so this is wrong, sorry, this is wrong. On x-axis 10 mm is equal to 30 degrees and y-axis 10 mm is equal to 10 mm itself. Now let us draw a horizontal line AB of any arbitrary length. Draw a vertical line AC such that AC is equal to lift of the follower, that is 30 mm, and complete the rectangle ABCD. On AB mark AE, EF, FG, GB, representing the outstroke 40 mm, that is as per the scale for 120 degrees, 12 10 mm for 30 degrees, and return stroke 40 mm for 120 degrees, and 12 for remaining part of 30 mm for 90 degrees respectively. Mark CM, MN corresponding to AE, EF joining AM and GN. Divide outstroke and return stroke into same number of equal divisions. And this division should be 6 divisions or 8 divisions, but that means even number of divisions. And draw vertical lines from each division, say 1, 2, 3, 4, 5, and 6 to meet the line AM at A, B, C, D, E, F also. In the same way, the points A dash, B dash, C dash, etc. to obtain the block representing return stroke. And here is the, so AB is equal to 360 degrees and AE is equal to outstroke and EF is equal to return dwell period, FG is equal to return stroke, and remaining part 90 degrees is the dwell period. And here in this case, divide this outstroke and return stroke into same number of equal parts. That is to even number of return parts generally, and draw vertical lines from each point, and also join AM, which will intersect all the vertical lines at A, B, C, D, and E. And similarly, here also in the return stroke, draw N and G, which will intersect at various points of vertical lines. One will intersect at A1 and B dash, C dash, D dash, etc. So by joining these lines, you are going to get your displacement diagram for uniform velocity. And now draw the cam profile with O as center. Draw a circle with the 25 mm radius. Mark angular displacement for outstroke 120 degrees and dwell 30 degrees and return stroke 120 degrees. And divide angle of outstroke and angle of return stroke into same number of equal parts as that on displacement diagram. Obtain the points A, B, C and A dash, B dash, C dash, etc. corresponding to the displacement of the follower at the position shown. Draw a curve tangent to the face of the follower. And this curve represents the profile of the cam. Let us see this figure. So here in this case, in order to draw this cam profile, first of all, take center O and with radius given, minimum radius given for us. With that radius, draw a circle which represents the base circle and mark follower on the circumference at say this is the flat follower, and from point A will be the, here is the point, that is trace point. So 0, this will be 0, and from O to 0, starting from here, assuming the cam is rotating clockwise direction and follower is moving in anti-clockwise direction. So that's why from O to 0, starting from here, mark 120 degrees to represent the outstroke, and also dwell for the 30 degrees of rotation, and again once again 120 degrees for return stroke, and left to 90 degrees will be the dwell period. So next is divide this outstroke into same number of parts as done as we completed in displacement diagram, as well also in return stroke, and join O1 and produce it, and O2 and produce it, and O3 produce it, and O4 produce it, and O5 and also produce it. Similarly here also O5 dash produce it, O4 dash produce it, and O3 dash produce it, and O2 and produce it, and so on. After this, mark points from 1A dash, sorry, A, by taking from the, by transferring the distance of in displacement diagram 1A to here also, and draw a flat, perpendicular line to this line, and similarly 2B draw one perpendicular, and 3C and draw one perpendicular to this line, and similarly for all the divisions, and draw tangents to these perpendicular lines for each, which will give you the cam profile for a flat faced follower. This is a simple method to draw the cam profile for a flat faced follower. Next, flat follower with a simple harmonic motion. Flat follower with simple harmonic motion, let us see. Here is the problem. A cam drives a flat reciprocating follower in the following manner. During first 120 degrees rotation of the cam, the follower moves outwards, that means 100 degrees outstroke through a distance of 20 mm. That is lift of the follower with a simple harmonic motion. The follower dwells during next 30 degrees of cam rotation, first dwell, and during next 120 degrees of cam rotation, the follower moves inwards, that is return stroke with a simple harmonic motion. The follower dwells for the next 90 degrees of cam rotation. And the minimum radius of the cam is 25 mm. Draw the profile of the cam. So, and the data is given for us. Here is the flat faced follower, and number 2 is simple harmonic motion for both the outstroke as well as return stroke. So let us solve this problem by drawing displacement diagram as well as cam profile graphically. Cam rotation during outstroke 120 degrees, cam rotation during dwell 30 degrees, cam rotation during return stroke 120 degrees, cam rotation during remaining dwell period is 90 degrees, and stroke is 20 mm, and minimum radius of cam is 25 mm. Now displacement diagram, here you can see this displacement diagram as it is that see here, draw A to X, which is equal to 360 degrees of cam rotation by taking suitable scale, and perpendicular at point A, perpendicular to this horizontal line, draw vertical line AY, which is equal to lift of the follower, that is 20 mm, and complete the rectangle A, Y, and like this, X and A. After completion of this, mark AS, which is equal to outstroke, and ST, which is equal to dwell, and TP, which is equal to return stroke, and PX and dwell P. And once again, divide this line, this AS as well as TP, into same number of equal parts, and draw vertical lines at each point in both outstroke as well as return stroke. And similarly, draw a semicircle with the diameter AY, that is stroke length or lift, and divide this semicircle into same number of equal parts as done in the outstroke as well as return stroke. So that will give you A, B, C, D, E, and finally F. And here, from each point of semicircle, draw horizontal lines to intersect the various points of outstroke and return stroke, various vertical lines of outstroke and return stroke. So by taking A intersecting first line 1 at point B, and second line of horizontal line at point C, and similarly point D, E, F, G, and similarly here also in return stroke, mark all the points wherever they are intersecting, and join A, B, C, D, and so on, G, H, J, K, L, M, N, O, P, and up to X, which will give you the displacement diagram when the follower moves with simple harmonic motion. So this is a simple procedure. Let us see once again. Since the follower moves outwards and inwards with simple harmonic motion, therefore the displacement diagram is as follows. Draw horizontal line AX 360 degrees to some suitable scale on this line, and mark AS 120 degrees to represent outstroke, and ST 30 degrees to represent dwell, TP 60 degrees, sorry, this is not 60 degrees, this is 120 degrees to represent the return stroke, and PX 90 degrees to represent the dwell period. Draw vertical line AY, which is equal to 20 mm to represent the cam lift or stroke of the follower, and complete the rectangle. Divide the rectangular displacement, angular displacement during outstroke and return stroke into any equal number of even parts, say 6, and draw vertical lines through each point. Since the follower moves with a simple harmonic motion, therefore draw a semicircle with A as diameter and divide into 6 equal parts as we did in the outstroke and return stroke. From points A, B, C, etc., draw horizontal lines intersecting the vertical lines drawn through 1, 2, 3, 4, etc. up to 6, and similarly 1 dash, 2 dash, 3 dash, etc. up to 6 dash. And the intersecting points are B, C, D, and M, and up to N. And join the points A, B, C, etc. with a smooth curve as shown in figure. This is the required displacement diagram. And now, after completion of the displacement diagram, let us draw the cam profile. Construction of cam profile, let us see. Now the profile of the cam driving a flat reciprocating follower is done as discussed in the following steps. Draw a base circle with center O and OA equal to the minimum radius of the cam. So that is 25 mm given for us. And draw the AOS. It means this is the center of the cam and OA as the radius. Draw the circle which is representing the base circle and draw angle AOS. That means AO up to this point, say let us S, which is representing the outstroke of the follower, and after that angle SOT, this is SOT here, and this will represent the dwell period, and TO and P, which will represent the 120 degrees of rotation for inward stroke or return stroke, and divide the outstroke angular displacement and also return stroke, that is divide the angular displacement during outstroke and return stroke, that is angles AOS and TOP, into the same number of equal even parts as in the displacement diagram. Join the points 1, 2, 3, etc. with the center O and produce behind the base circle. From points 1, 2, 3, etc., set off 1B, 2C, 3D, etc. equal to the distances measured from the displacement diagram. That means 1B, 2C, and then 3D, 4E, 5F, etc. and also 6G and 0 dash H, 1 dash, etc. We have to complete this. And now at points B, C, D up to NP, draw the position of the flat-faced follower. The axis of the follower at all these positions pass through the cam center. The curve drawn tangentially to the flat side of the follower. That means for this flat face, the curve tangentially we have to draw. That will give you the required profile of the cam and complete the profile. So like this we can complete a flat passive follower with the simple harmonic motion. Now let us go to the flat follower with uniform acceleration and retardation. Flat follower with the uniform acceleration and retardation. And here is the problem. Let us see a flat follower with uniform acceleration and retardation. Problem is, draw a cam profile using following data. Follower rises for 120 degrees of cam rotation, and follower dwells for 30 degrees of cam rotation, and follower descends for next 120 degrees of cam rotation, follower dwell for the rest of the motion. And stroke of the follower is 30 mm and minimum radius of the cam is 20 mm. And axis of the follower passes through the axis of the camshaft. The follower moves with uniform acceleration and retardation during both outstrokes and return stroke, both the strokes. So here is the motion for the follower is uniform acceleration and retardation. The follower is flat-faced follower, stroke is 30 mm and the minimum radius is 20 mm. So first of all, let us draw the displacement diagram. Cam rotation during outstroke 120 degrees, dwell 30 degrees, and return stroke 120 degrees. Cam rotation during the next dwell period is 30 degrees. And stroke of the follower is 30 mm and minimum radius is 20 mm. So here is the construction of displacement diagram. Here you can see this displacement diagram. Mark OX equal to the 360 degrees of cam rotation for one revolution, and similarly OY equal to the stroke length, and complete the rectangle, right? And divide this OX into OA and AB and BC and CX, which represent the OA represent the outstroke, and AB dwell period, and BC represent the return stroke, and CX represent the dwell period. And now divide this OA outstroke and BC return stroke into same number of equal parts, even number of equal parts. And here we have taken 6 parts, and draw vertical lines from each point for both outstroke and return stroke. And from middle point, say 3 here in this case and 3 dash in this case, divide this vertical line stroke length into same number of even number of equal parts, say A dash, B dash, and so on. After completing this division, join OA dash, which is going to intersect first vertical line at point A, and also O D1 D dash will intersect at point B, and O C dash will intersect at point C. This is for uniform acceleration. After some uniform acceleration, and it will retard. So that's why starting from here we have to take, and A dash E dash we have to intersect, which will give you the point E, and A dash D dash, which will give you the point D for a vertical line of 4 and 5. So after joining, after having point A, B, C, D, etc., and join with O, A, B, C, D, E, and capital A dash, will give you the displacement diagram, which is showing the double parabolic shape. This is the displacement diagram for outstroke, and similarly the same procedure is to be adapted in this return stroke also. 3 dash vertical line should be divided into same number of equal parts, and similarly join from C for acceleration and C dash for retardation, right? And complete the displacement diagram. And for this drawing of this displacement diagram, we have to take x-axis 1 centimeter or 10 mm is equal to 30 degrees, and y-axis 1 centimeter is equal to 10 mm. So let us see procedure. Construct a rectangle as usual, marking lift 30 mm on y-axis and cam displacement theta along x-axis as shown in figure, and mark OA, OB, BC to represent the outstroke theta 1 and dwell theta 2, and in stroke theta 3, and dwell for the rest of the period. And divide OA and BC into 6 equal number of parts as 1, 2, 3, 4, 5A, and B 5, 4, 3, 2, 1, and draw vertical lines from each of these points. And choose the mid vertical line at 3 and divide it into equal number of parts, say A dash, B dash, C dash, D dash, E dash, etc. Similarly for return stroke also. And join OA dash, OB dash, O C dash, etc. And similarly A dash, C dash, and A dash, D dash, and A dash, E dash, etc. And join with a smooth curve points of intersection, that is A, B, C, D, E, etc. And of these lines with respect to vertical lines 1, 2, 3, etc. And similarly another curve is obtained in return stroke block also, and complete the displacement diagram. And now the cam profile, same as in the previous case. Draw a circle of radius 20 mm, which is equal to 1 centimeter is equal to 20 mm, and draw OA, and OA produced represent the follower axis. Mark angle OAB equal to 120 degrees, and OBC 30 degrees, and OCD 120 degrees, starting from OA. And divide arcs AB and CD into equal number of parts, 6 in each sector, say 1, 2, 3, 4, and 6, 5, 4, 3, 2, 1, 0. And draw radial lines through these points, and measure 1A, 2B, and etc., and 1A dash, etc. And similarly, off on these lines as measured from the displacement diagrams. Draw a small perpendicular lines from A, B, C, etc. say, and they represent contact of flat surface of the followers. Draw a smooth curve tangential to these lines. Curve gives the required profile. Let us see once again. With center O and A as the radius, draw a circle which represents the base circle, and starting extend this OA, which is going to show the follower axis, and mark the follower on the circumference of the circle, and starting from OA, mark angles 120 degrees to represent the outstroke, and 30 degrees dwell period, and return 120 degrees, and remaining 90 degrees for dwell period. And draw radial lines from, divide this 120 degrees and another 120 degrees into same number of equal divisions as we did in the displacement diagram, and draw radial lines starting from O, from each point O1 and produce it, and O2 produce it, and O3 produce it, and similarly all the lines are to be produced. And draw perpendicular lines at each point by marking 1A from displacement diagram, 2B from displacement diagram, 3C, etc. from displacement diagrams, and draw a line tangent to these flat lines, perpendicular lines, which is nothing but the displacement diagram, cam profile for the given flat faced follower and given angles. Curve gives the required cam profile. This will be the all about. So in the last 4 lessons we completed. This, let us say, knife edge follower with uniform velocity motion, simple harmonic motion, and uniform acceleration, retardation also we completed, and also we completed roller follower with uniform velocity, simple harmonic motion, and uniform acceleration, retardation. And in today's lesson we completed flat follower with uniform velocity, simple harmonic motion, and uniform acceleration and retardation. So with this we completed this CAM's topic. Let us have a small summary of this. This will be the CAM profile for present problem. And summary of this discussion, we have discussed the procedure to draw the CAM profile when the flat follower moves with the uniform velocity, flat follower moves with the simple harmonic motion, flat follower moves with uniform acceleration and retardation. And let us have a small quiz on this lesson. The type of follower recommended for slow speeds. Knife edge follower, flat follower, roller follower, and then spherical follower. Which is the right answer? Spherical flat follower is. Which is the right answer? Let's say for slow speeds. For slow speeds, let us have the answer. flat follower for slow space. In displacement diagram, that is taken on y-axis. Dash is taken on, for in displacement diagram, dash is taken on y-axis. Lift or stroke of the follower. And next is stationary period of follower during a part of cam revolution is called stationary period. That means rest period. That means the follower is not going to move either upwards or downwards. It is remaining stationary. That is called, as per our knowledge, that is the dwell. Right? Next is dash is the outline of the disc cam on which the follower is always in contact during rotation. Dash is the outline of the disc cam on which the follower is always in contact during cam rotation. That is nothing but the cam profile. Right? Now let us have a small assignment from each of the present discussion. Draw the profile of a cam to give the following motions to the reciprocating follower with a flat face, that is flat face follower. Outstroke 1/3 revolution of the cam. 1/3 revolution means 1/3 1/3 into 360 degrees, which will give you 120 degrees of cam rotation. And dwell for the next 1/12th revolution, that means 1/12 into 360, that is nothing but the 30 degrees of cam rotation. Return stroke for 1/4 of revolution of the cam, that is 1/4 into 360 means 90 degrees. And dwell for the remaining part of cam rotation. The stroke of the follower is 25 mm and minimum radius of the cam is 50 mm. The follower moves with uniform velocity during both the outstroke as well as return stroke. The axis of the follower passes through the axis of the shaft. And this is another draw the profile. This is for simple harmonic motion, I think. And the next is assignment is uniform acceleration and retardation. And thank you for hearing. Thank you.